Just a bit of background about myself. I've been involved in the hydrogen and fuel cell sector for probably more than 15 years, nearly 20 years. That includes doing fuel cell technology, as well as ULEMCo, my current business that I set up in 2014, where we're building a portfolio of solutions to commercial vehicles and how we can use hydrogen to decarbonise them. I'm also deputy chair of the UK Hydrogen and Fuel Cell Association. One of the things I want to try and focus on is what we can do now. I respect the fact that the series is called Future Technology, but in the most of the people that I deal with, they're looking for what vehicles can they buy to change now and their fleet and start to deliver their fleet now. So hopefully I'll address some of the questions that Philippa asked Simon earlier. I just want to say we've been really reflecting the other speakers. The interest in hydrogen has increased massively. We've just completed, well, we've done over 100 vehicles currently on the road using hydrogen to reduce the carbon emissions of the diesel fleet in the UK. And we just completed a bulk order, or bulk for us, 20 vehicles for Glasgow City Council that will be on the road as soon as they get the hydrogen infrastructure. And Philippa, given your perspective is on infrastructure, hopefully I can show how important that's been. Here's the answer to the question in terms of what might happen and what we can do practically now to take all the big picture modelling stuff that talks about 2040 and actually reflect on how we can do something within our overall requirement to reduce carbon emission. Let's not forget that we have probably at current emission rates less than eight years on current carbon budgets to keep global warming below 1.5 years. 8 years is half of the lifetime of an HGV asset on the road, albeit, you know, we're talking macro level figures. And therefore, I kind of make us realise that 2040 net zero by 2050, those kind of targets isn't what we should be doing. We should be finding ways to reduce carbon emissions now. And that way, you know, the carbon budget that we're working to already allows us to see the back of the glaciers in Canada and more than half of the coral reef in Australia, and I don't want to see that happen, and neither should most of the rest of us do that. So green hydrogen, actually, for most of us involved in it, describes for us a no-brainer. If you can use in current renewable energy grids any of the electricity that's curtailed, that's grid stranded, or for that matter, help provide a better business case for the investors in putting more renewables into the grid, then one imagines we should be doing it. And that's what's reflected here. The industry in the investors for green hydrogen have said within the next few years, like by 2025, we have an ambition to have 5 gigawatts of hydrogen that could be deployed in all the no-brainer scenarios that would make sense. And actually going forward, that would facilitate getting to the 80 gigawatts that the Climate Change Committee says we ought to be trying to achieve for the total energy system. So what does that really mean in the here and now? Well, 5 gigawatts of renewable, green, stranded, no-brainer hydrogen would represent about 400,000 tonnes of zero carbon transport fuel. It's not debate, it has no carbon in it, it will have had no carbon in it, there's not even any side uses. Yes, if you could use that electricity in a vehicle straight away connected to the grid, then obviously that would be a very efficient thing, but all the previous speakers have confirmed we know we can't do that as an example for the 500,000 HGVs that we have running in the UK in our car park at the moment. The other part of the story is how do we make that at less than £5 a kilo, €5, what a colleague at FEV explained. Well, what you do is you consolidate demand around a local facility that can divide the compressor infrastructure costs to make sense. And ultimately, all the modelling says that's anywhere actually between 250 kilos a day and 500 kilos a day, which is sufficient for round trip supplies. So back to base locations for vehicles that will conveniently do daily ranges coming back to a location. And those are the vehicles that people like construction operators, construction vehicles, regional logistics, utility vehicles within the public sector, and the buses. And those are the kind of examples that would be practical now within the next 5 years to use this lovely, good, low carbon hydrogen that would be benefiting the overall energy system. Just a little bit about us. So as I said, we're building a portfolio of hydrogen solutions that can go on commercial vehicles. But I put this up to try and illustrate the here and now and the future. We have a technology, hydrogen dual fuel, where we can display significant volumes of hydrogen now. It doesn't require asset replacement programs for the vehicle owners. It doesn't require them to change their operation. It actually also can provide better air quality emissions, and it costs a significantly small proportion in comparison to the price of the new vehicle. That's not to say in the future, the kind of developments that colleagues from IE are talking about, that we wouldn't want to have fuel cell technology to do the job at some stage in the future. But I would put it into context. The bus programme that has made fuel cells available commercially and fantastic opportunities with Wrightbus and the others in the UK has been as part of a programme to develop the technology probably for the last 15 years, certainly 7 to 10 years. So if we want scaled opportunities for fuel cell technology, it isn't going to happen in that window of time for the availability of using that lovely green hydrogen that's good for the planet. Just to confirm the importance of infrastructure in that story, we completed a trial of dual fuel vehicles, and our point was to demonstrate the range and breadth of vehicles that we could put the technology on and still deliver significant emission reduction. So our contribution in the low emission freight trial had 11 or 12 different vehicles, different manufacturers, different types of vehicles. Across the board, they all showed if you use green hydrogen, you can deliver a significant proportion of or reduce emissions by displacing a significant proportion of the diesel on those vehicles. Importantly, in a day-to-day operation, the biggest reason why those vehicles did not operate on hydrogen over the annual basis was the lack of reliability of the infrastructure. And you know, the biggest reason you can solve that problem is to have them being used regularly in a location, funnily enough, in a back-to-base fleet with using lots of vehicles, using the compressors and keeping them running. So finally, just to kind of set that into context, what does it really mean if we look at some of the options or the forward forecasts of what might happen to 2050 in decarbonising our fleets? And the numbers behind this have been based on things like Zemo's published renewable energy alternative fuels, scenarios for electrification. And if you look for the next 10 years, no matter what we choose to do, rightly bringing on really good technologies that will be part of the future, we want to stop emitting CO2. We should embrace the idea that if we use biogas, that helps us to address things like the 44-ton vehicle market. It's a much better, better thing to do than to have those as diesel from a CO2 perspective. But there still remains a whole fleet of other types of vehicles that will be diesel and will be bought new as diesel. And even if we set a target that says we will ban anything other than alternative fuels by 2035, we'll still be on the fleet for the next 30 or 40 years time. And fundamentally, having a solution that says we can use green hydrogen or decarbonised hydrogen as the gas grid embrace CCS technologies to make sure that the hydrogen is blue or any other rainbow colour, frankly, we have an opportunity to significantly reduce CO2 emissions in the next few years and help build the infrastructure that will ultimately service more than half of what our future fleet of HGVs are going to need as hydrogen to be decarbonised. And to set that into context with the ULEMCo's technology using dual fuel, if you took a refuse truck at the moment, the 400,000 tonnes, they probably use between 5 and 10 kilos a day as a percentage of their diesel use. We could convert more than half of the UK's refuse truck fleet to running on a proportion of diesel. That would seem like a good thing to do. And then the rest of it might go into doing buses or road sweepers or other utility vehicles clustered around locations, such that by 2030, instead of continuing effectively the way we are, we can reduce emissions. And I'll just quote from Greta: hope comes from action, and we need to start actually having action now.